we'll start with our session. So welcome everyone. Good evening. So I'll welcome you to this webinar series of Dynamic Hackathon. So Dynamic Hackathon is an exciting event or a hackathon focused on driving innovation in crane and metal handling industry. So this hackathon is a unique opportunity for students to revolutionize crane safety solution and machine health using IoT, AI, predictive analytics, and IoT sensors, LiDAR systems, all the newest technology that being used in the industry currently. And this hackathon is organized by Dynamic Crane Engineers Private Limited and powered by IFOC, that is Enter Inclusive Innovation Center. So this hackathon will provide participants an hands-on experience, industry mentorship, and chance to win exciting prizes as well, and solve real-world problem statements and challenges. So we encourage all the attendees to register for the hackathon and submit your innovative idea. So don't miss out the chance to collaborate with the industry experts as we have today and showcase your skill. So Shubha, I welcome you to the webinar on revolutionizing machine health with IoT. So my name is Saurabh Pugade. I'm Manager Innovation at IFOC. I'll be host for your session today, and we have exciting and insightful discussion lined up with our esteemed speaker, and we can't wait to get started. So before I introduce our speaker, a couple of quick points to remember. So this webinar will last around approximately 45 to 50 minutes and will include Q&A session at the end. Feel free to post your questions in the chat box and we will address them. And if you experience any technical difficulties, please log out and log in back. Thank you. Please remember these points. And now let's meet our incredible speakers. So we are honored to have with us today Dr. B. Venkatalakshmi. She is lead subject matter expert at L&T EduTech. So she is passionate educator with teaching research nexus skill set with 30 years of experience in engineering education. Her contributions span teaching, research, and administration. As a recipient of the IBM US Faculty Innovation Award in 2010 on the Smarter Planet scheme for content development, she has been actively working on design and development of engineering curriculum, teaching pedagogics, and evaluating strategies for engineering fraternity. She specializes in content creation for engineering learners in niche areas like Industrial IoT, AI, edge computing, 5G, and SoC design, aligned with the real-world industry applications. So with strong commitment to outcome-focused education, she continuously works on designing solution, learner-centric, and engagement-driven content. She is also an expert in applying design thinking in caption project development and mapping skill-based job roles. So I welcome you, ma'am.
Thank you.
And we are excited to have you today. So now as we are all set, so let's dive into today's discussion, and I hand it over to you, ma'am, to kick off the session. Thank you.
Thank you, sir. Thank you, sir. Just confirm whether my screen is visible.
Sure.
And am I audible too?
You're audible, ma'am.
Yeah. Hope screen is visible.
Yes, ma'am. Your screen is visible.
Thank you. Let's begin.
Sure.
So very good evening to one and all present here. I would like to thank Dynamic as well as IFOC for this opportunity to give the glimpse of excitement for the fresh graduates, those are assembled today, in order to just make you to think of unique solutions for the real world industrial problems. And I would like to share some of my viewpoints onto the revolutionizing the machine health with the technologies of IoT and AI, which will be a kind of a thrust for you to think about your solution which you are planning to develop for the Dynamic Hackathon. I will also guide you with some of the tips which you can just have it as a takeaway today, so that in that path you can just try thinking and developing a solution for the hackathon. So with this small brief, I would like to start today, and I welcome you once again, and I wish you all the very best for this hackathon. Where there's a hackathon, I would like to visualize it. It's actually you're going to apply your knowledge onto recent trends and onto a real world problem, which I myself feel very much exciting because that is a requirement of today's engineers, particularly in India. So you're at the right place now. So let's have a small overview on what is that we will be discussing for the next 30 to 40 minutes. So first, I will try to say what's the motivation to have this kind of a solution in the hackathon and why to do the machine health monitoring, which I have abbreviated here as MHM. What's the need for it? And then I will have only a brief on IoT and AI. Let me not have much more deeper insight because the focus is different. I will introduce you how IoT and AI is useful for MHM, but as a technology, I will just give you glimpse about it. Then I will touch upon how this IoT and AI architecture is there for the machine health monitoring industries. And having set with all these three steps of information, now what is that relationship with our dynamic hackathon? I will point out next agenda. Then after that, I will be able to give you a framework of the solutions and methodology, how you can draft your solutions. So this is an overview of my discussion today. So to begin with, what's the motivation and why to do MHM? I would like to straight away take the example of a crane. There are a lot of machineries which are around us today. We are living in a third era of computing. I hope many of you know computing means taking some data and do the process and give some comfortable output for all of us. Where we are living in the era of third era of computing. What does it mean? In the first era, we had mainframe computers, which was a single machine where anyone, those who wanted to do some calculations, those who wanted to do some storage, or those who wanted to have some filtering, everything they will feed, and that single machine will do multiple users requirement and it will give an output. That was the first era of computing. Later, as we had a parallel growth of the semiconductor growth and other communication technology growth, we were able to come back for a personal computer, which is one computer for one person, in order to do some of the requirements of the computations what the person wants to do in a professional mannerism. And that made our second era of computing. Moving on, we are now today with third era of computing. What does it mean in the third era of computing? One single person's requirements are today attended by multiple computing devices. If you take today, I'm talking to you through my laptop. So I'm attended by this laptop. I'm using my laptop, which is one of the computing device. I have the mobile phone, which is the second computing device. And many of my requirements today, I carry my laptop and mobile together. I also wear a smartwatch where I'm able to have some of the computations required for my personal track, which means for my lifestyle, I'm just connected with multiple computing devices. That's how today we are in a third era of computing. If a person's life is enhanced like this, how about the industries? Industries are having quite many number of machineries, and each of those machineries we wanted to have without any damage the monitoring so that the manpower is comfortable in handling those machineries. So one small video I just would like to play. I think the audio may not come. Once again, I'll stop sharing and start sharing with the audio. Just give me a minute. Yeah, I think now the audio will come. Let me play the video. You can just have it for 1 or 2 seconds so that you can understand the importance of going for this kind of a hackathon. Hope you're
From a
able to
crane
see.
collapse in Russia that you could easily blame on gravity, and a disaster in Indonesia that nearly totaled these cars, to crane on crane violence in Sochi that definitely cost someone their job, and much more. Here are 7 massive crane failures that were caught on camera. The Malang Regency is the second largest state in East Java, Indonesia. It's home to about 2.6 million people living between 33 districts. This crane clip comes from Turin, one of the largest districts in the middle of the state. It was June 2nd of 2020. A tree removal team was dispatched to deal with a thick trunk that was threatening the power lines. After removing the leaves and branches, they were left with the core of the massive tree. Since cutting it down all at once was too dangerous, they decided to take it apart piece by piece. Someone clearly underestimated how heavy those pieces were.
So I hope you observe the video. Two inferences impacted me on seeing this. This is from Indonesia, which is a place where often the earthquakes also happen, where this kind of necessary facilities are mandatory for such a population, number one. And number two, it's not a very old video. Recently, by 2020, this incident has happened. See, a mankind can announce themselves they are safe and good in the earth only if the technology is really making their life comfort. But today, these kind of accidents make us to think really about how to solve it. And who can solve it? Except you, the engineers. You are the solution providers for the real world problem. So which means we are at the right place to understand about how to develop kind of solutions for this kind of massive kind of a worst incidents is happening, right? So since I felt other machineries, crane is the best example. I've taken this video. Now moving on, when you take one example from our premises itself, this is one of the vehicle which is called a concrete mixer vehicle in our remote site. You know very well, L&T is famous for construction business. So this is normally rotating and then it makes the cement to have the correct humidity and it will push out with the product, which will be taken by the manpower and then the buildings will be constructed. When this machine in the remote site is supposed due to some failure, if it is off for even 1 hour, we will face a loss of more than 1 lakh rupees because cascade to the downtime, we call it as a downtime. Cascade to the downtime, the manpower, what we planned is waste. Any of the other rented items, if we have acquired for the project, that becomes a waste. Totally our production, if it gets affected for 1 hour, we'll be facing 1 lakh of rupees. Today, we have overcome such a problem with the help of IoT. We just attached a small gateway device, which I have shown in this particular diagram as a red color circle, which is able to help us to sort out prediction of any such issues happening in this vehicle. So like this, we have already connected more than 100 vehicles in our projects. And this gives us engine optimization, resource planning, prediction of failures, etc. Right? So this is the kind of the gateway which I have mentioned. This is around some 2,500 rupees cost device, right? So this is one scenario where the machines are or the vehicles are connected with IoT devices. Now, why this machine health monitoring? Early detection of the actual prediction of failures. So predictive maintenance, regulatory compliance, performance optimization, optimal decisions. These are the benefits which makes our solution to be essential. So I'll be able to get the entire information like this. What is the predicted failure rate? And what is the kind of the power level, temperature level, etc., which helps to the extent possible my machine's health to be monitored closely, right? So having understood why MHM, now my next point of inference to you is how IoT can help in this particular machine health monitoring. So what is IoT when we look at? It's a very literal meaning. I can say anything which I connected with internet can be called as IoT. Of course, now I'm connecting through my laptop with the internet in order to talk to you, but this is not having any sensed data from my end. So IoT also has some data to be sensed from my end and then thrown to internet. That is nothing but IoT. That's a simple definition. When you look at in the IoT scenario, right, I can suggest you to keep as a simple definition for the IoT, a 3-word mantra, which is nothing but sensing, computing, and communicating. You can recollect the examples which I have shown also. The gateway device will have a sensor. It simply senses the condition of my concrete mixer vehicle. That sensed data will be computed locally within that gateway device itself by a microcontroller. There are ARM-based gateways available. What it will do in the computing, the collected sensed data will be in a very raw form. It will just process it. I have to filter the noise. I have to make it as a readable signal, and then I have to pass it to the next line. What is the next line? The vehicle which is available in a remote site, it is pushed to cloud of our L&T. So that's for communicating. So data is sensed and it's computed and it's communicated as such in IoT technology. So IoT technology can be read in a very simple manner. This picture, if you look at, there are machines attached with sensors, attached with different tools, and there will be some processing. So their sensed data could be processed and it can be thrown either in the local device or it can be connected to the cloud. Once if it's connected to cloud, it is IoT. If it's sensed in the local device, we call it as a local monitoring. Take example of your air condition. So already we have a sensor inside our air condition. What it does, it sends the temperature and accordingly the compressor is made to turn on or off and to get adjusted. So which means there are sensors, there are computations which are already available in many of the solutions. IoT comes into the picture when I wanted to throw that data to a far place in a remote way. So there comes Internet of Things. So for an Internet of Things, the basic mantra is sense, compute, and communicate. How could be the architecture? So this is a mantra. How can it be the architecture when you just look at this is how the architecture will look like. So what does it mean? The physical data available with any of the objects will be sensed by the sensors and it will be passed through the microcontrollers. So this is the computing device. This is the communicating device. Sometimes this communication and computing device will be put together as a single device also. So the procedure of your design will also be any solutions what you're planning for a crane can have this kind of a flow. So there is a physical data which I need to sense from the health of my crane, which has to be taken inside a controller and that has to be connected to cloud. This is a basic framework. Once if it comes to the cloud with the help of the gateway, then I can do a lot of analytics with the help of AI. So IoT helps me to take the data in a remote manner from a distant object. So IoT plays still that role. Once when the data comes and get accumulated in the cloud, I will be playing with the next technology called artificial intelligence. So this is how the layer will look like. I think this picture try to keep it in mind, which gives you a fair idea about any solutions, every candidate you wanted to play for the solution for the hackathon will have this kind of a segment, right? So having this understood, now I would like to give you how this scenario is in little in detail in the industry. So this is one of the heavy engineering vehicle, like the other example I have told you. This is another heavy engineering vehicle. If you look at this, we call it as an equipment or an object, which is going to be connected with the Internet of Things. It's a thing here. Now, I can fix retrofit sensors. So it could be a fuel level sensor, or it could be an engine oil pressure, or it could be some coolant temperature to be measured. In various positions, you are keeping the sensors, right? So this is the next step. After fixing the optimal point for fixing those sensors, next, these sensors are integrated through a gateway device. This is the device which is able to take my signal in the which is see these kind of vehicles are available in the remote place. It's not like my home environment where anything I speak, I have a Wi-Fi and I'm able to get through my modem to the internet. In a remote place, imagine like in Himalayas, if one project is going on and if this kind of a heavy engineering vehicles like trains are in work, how will I monitor their condition, right? So for which the best solution is the gateway through the mobile network. If you take this particular gateway, these devices are attached with a SIM card and they will be working with the mobile networks. Okay, so the next picture tells you like this is how through a wireless mobile network help, they will be pushed to the cloud, which is the IoT platform. I think this picture will give you the overall real-time requirement of a solution, what we are trying you to think and develop. I hope you understand that. So the data which will be captured from here goes to the IoT platform, right? And once when it comes to the IoT platform, there comes a logic of a software, where in the software, we will be able to just see how many equipments are connected, how many of them are under operation, and how many of them are still that are not operational, right? Is there any gateway not responding? What is the daily utilization? See the beauty of the software integration, which is able to help me sitting in Chennai office. I can monitor one of the crane which is available in the Jammu Kashmir project. Very great solution. How it is done? So far, I have explained the technology involved is the sensor, the computers, which is nothing but the microcontrollers, then the communication mechanism, which is nothing but some RFIC along with the SIM card. It's able to take the help of the existing mobile networks, maybe an Airtel or whatever the kind of a network. Through that, it is able to connect it to our server, and we are able to get the data as a dashboard in our front. Such a boon we can say the IoT is doing help for the industries. We are able to have different classes of the assets, and we can get a very practical solution like this, right? So till now, the kind of examples which I have shown to you, when I look at what is that we are doing, we select an appropriate sensor. What's the help of a sensor? Sensor will capture, say, for example, if it is a temperature sensor, it will measure at a particular point what is the temperature, and that physical phenomena will be converted into an equivalent electrical signal. That electrical signal is now given as an input to the microcontroller. I hope you will all know about the sensors. Why should I change it to an electrical? Only in an electrical domain, I have to process the signal. As such, a temperature cannot be amplified. So the converted signal can be taken for any process as an example. So once when I decide, these are all the sensors I'm going to fix on my object. Here in our example, the crane, for sensing some of the health or the issues available in the crane. Next step is how to install them on the specified location of my asset. My asset, in your case, could be the crane. So in the asset, where to keep the sensors will be the next part of your diagnosis. Once if you decide to fix those sensors, then you will connect them to the processor. That could be through either wired manner or a wireless manner. Today, a lot of sensors are coming in a wireless model also. So you can connect it, the sensor values, to the processor. And from the processor, we will be connecting them through for a proper communication. Then comes the communicated sensors will now have an integration with the monitoring software, those values. There will be some signal conditioning happening. Otherwise, I may not be able to see the values in a comfortable manner. So I just bring the integration of sensors with the monitoring software. And from there on, I will start monitoring the values from the sensor. So till this, my IoT helps. Saurabh, can you take a pass for any Q&A now, or is it a final session?
We can take it at the end.
Okay.
That okay?
Yeah.
We'll ask.
I'm okay.
If you are, dear participants, if you have any questions, please put it in chat box and you will get the question.
Yeah.
Chat box or Q&A. So
Okay.
yet we don't have any questions, but at the end we will definitely have.
We'll capture it at the end.
Yes.
Yeah. So let me proceed. So this is how the IoT works to capture the data for the kind of the asset to be monitored. Next comes the AI. So for just for having a linking purpose for the session, to have an understanding, I just brief some of the basics of AI. Some of you may be already aware of AI and might have developed some solutions using AI too. But for the continuity purpose, I would like to say the father of this particular technology is John McCarthy. It is not a new technology, guys. Starting from an Excel data to be analyzed, we started thinking about an intelligence in the solution of the computers. But when the volume of the data keeps increasing, there is some strategic algorithms required that forms a new branch of science called AI. So the science and engineering of making intelligent machines. especially intelligent computer systems, is called AI. Already your computers are actually having an intelligence. Similar way, AI is also an additional intelligence you add on to it. But do not forget that intelligence, as a human being, you are only guiding for your computer how to take such a intelligence, how to behave. So there are a lot of advanced mathematics when we keep applying onto the intelligence, we are able to bring out huge potential of different methodologies where the data can be played. All this started when the data volume got increased. If you take the era of computing, in 1970s to 80s, there was a good growth of a kind of railway reservation systems, and banks and all started having digital data. Once when the data volume keeps increasing and exploded, people started looking about what to do with this data. When they started reading the data, they get a lot of ideas how to connect the data and come for an inference. Then they wanted to make it. See, in even our daily life, or in any of our regular activities, if you want to take a decision, I may keep one criteria or two criteria or three or four criteria. But if you wanted to keep n many criterias, by human brain, it's not possible. But if you feed all that criteria as a decision constraint onto a machine, and if I instruct the machine to take a call and prioritize these criteria first, if four criteria are like this, and then take next five criteria and cross verify, I can tell any instructions through my coding. Computer is capable of doing. That gives me a lot of precision in my outcomes and decisions. That's how the AI came in, and John McCarthy has found such a path for making a complex computations and to have a efficient decisions. Thus, artificial intelligence is the way of making a computer or a computer-controlled robot or any other software to think little more intelligently in a similar manner how the humans think, right? And to have another view, I don't want to talk about the first phrase, it's a very common phrase. So what it will do, in a AI, the two major classifications are the AI is a technology, ML and deep learning are the two different branches by which the data could be played with the different algorithms. ML deals with mostly the discrete data, whereas deep learning is able to play with the images by taking each image as segments and volume of data could be more. But deep learning can also be applied for a discrete data. But the two major principles, okay, deep learning and ML are two major branches, where if you take what is ML, it's nothing but a function. You must have learned mathematical functions. So it's a function, computer program, which is able to learn from some experience. So I'm training the machine to get some experience. So it acquires E, and with the E, it is trying to do a task T, and it shows some performance. If the performance is so much deviated, I try to increase its experience. That's what is simply the kind of machine learning. And the performance is directly proportional to the kind of experience the system is undergoing. Okay, so that's how the machine learning is defined. So now, where comes the value of AI into my total solution, which we are now focused and interested with? Already I have shown you the framework of how an IoT collects the data for a remote vehicle. Now in this screen, I am repeating that same picture, whereas the gateway collected the data from any of my object, example, a crane. Once in every 5 minutes, I'm able to capture some of the values from the crane. Many sensors may be in the crane, so all the sensors value may come. So I have organized, I wrote a code, and then I am organizing the data to get stored in the cloud. Now, my AI algorithm plays with that data. So I'm writing or building a model which read the data, which makes a experience, and then which is trying to do a task. What is a task I can command? I can ask it, is there any issues available with my crane? Not immediate. I mean, after broken, we are not ready. This is I'm trying to predict, where I'm asking the question or the task given for the AI model of my case is, based on the data observed from the sensor, do you anticipate any problem in my crane? Should I make any additional fuel? Should I clean any place? Should I replace any of the small components? such decisions I can take it based on the inferences created out of the AI. So AI is helpful once when I collect from multiple sensors, from multiple time, the huge volume of data, I organize it and then I run an AI model. That gives me some inferences in my device. So what is it happening in this framework? A marriage between the IoT technology and the AI is able to give the user friendliness and a solution for us, which is very helpful for us in order to take predictive decisions. As I told you, one example, such predictive decisions will avoid the loss in my business. So that's the reason today every industry is looking for digitalization of their assets. And that's why we are all here, where the crane manufacturers are also looking for how to have the failures or the accidents to be avoided in my usage of uh, than the kind of maintenance. If you are able to save even one life by avoiding the accident in a particular crane, the video which I have shown, because of the heavy weight, it was completely broken. Right? I mean, it was breaking totally, maybe making an accident. If I'm able to save even one life, that's a huge benefit because of the technology. That's what the technology has to be in our perception. I hope you agree with me. So this is the framework of solution which I'm trying to keep you in mind, right? I think this video already Saurav Matt has shared with you. Still, I would like to just play it for you people to have an understanding. Is there any such solutions available practically in other areas? You can just watch this, how AI is able to help for a particular machine health monitoring.
Nowadays, manufacturing companies are using AI to monitor the workplace. However, due to a lack of human resources who handle AI and an unpredictable judgment basis because of black box algorithm processes, manufacturing companies are facing challenges to realize monitoring by AI on site. NEC's invariant analysis technology collects and analyzes a large amount of data, automatically models the invariant relationship of the normal state of equipment, compares the predicted value obtained from the model with the actual measured data, and accurately detects changes in real time, is comprehensive and continuous before any issue occurs. Current on-site staff can handle this technology even without having analytical expertise, such as IT and statistics. Nippon Steel, Japan's #1 steel maker, had many unknown equipment failures even experts had never experienced due to the increasing burden on their facilities caused by advanced customer requests. They were facing the limits of predictive detection by conventional threshold management. So, based on the measurement data from more than 2,000 physical sensors, the behavior of the device is automatically modeled by AI to prevent trouble. Since it is possible to find the signs of failure that are difficult to resolve and visualize the basis, the cause can be identified and the recurrence of trouble can be prevented. Invariant analysis technology is also used for quality control and performance evaluation using sound. Since it learns as a normal state even in a noisy environment, abnormalities can be easily detected. In the past, it was difficult to distinguish abnormal sounds in a noisy manufacturing site. However, invariant analysis technology learns as a normal state even in a noisy environment, making it easy to detect anomalies. Therefore, it is possible to monitor a wide area with a small number of sensors using an ordinary microphone. So sound monitoring can be applied to a wide range of works. By utilizing invariant analysis technology that can be used on manufacturing sites, NEC realizes smart monitoring by AI.
So though it sounds like it's a very type of a big technology, I don't feel it is very, very new for us, I can say. conventionally, I can take an analogy from our physical body itself. Suppose if I'm having a cold or a cough, I may go to the doctor and doctor may treat me having checking with it's a viral infection, they will say, and they will give me a treatment. Suppose if a person gets continuously this viral infection with a period of a very short span, the doctors may ask you to take one X-ray, or they may ask you to just consider for one more body checkup. What does it mean? In my health, like because of that continuous, it's a symptom. When I have the continuous issue of that viral infection, it is some a system onto my immunism is not able to reflect. Whether is there any other parts of my body has got the impact. For that, the diagnosis they wanted to go for one more additional checkup, which means I'm able to get the prediction of my internal organs to be tested because of this. So this is the symptom. So the invariant analysis is actually like I'm supposed to have even cold is okay, cold and cough is okay, but it cannot happen at this frequency is the variation. So the invariant analysis talks about invariantly the parameters from the machine has to be like this, but there are anomalies and the anomalies are huge. Anomalies frequency is more. It talks something about my machine. Such a precision today with the help of electronics we are able to capture. That's the growth. So the concept is very simple from our health itself. Say, for example, if you take diabetic retinopathy, there may be an issue you must have heard. It's nothing but normally diabetes are today become a common disease for many of the public today. Whereas as you grow with the number of years of diabetes, the vision is expected to be affected more. It's a more prone organ. In order to, some people, if they have continuously for more than 15 to 20 years of diabetes, they may lose their vision. It's the actual logic by the medicine. So what will happen is the doctors will have the regular 3 months checkup of the diabetes values, and they will keep monitoring those values. By correlating some of the values, they may come to a conclusion that this value's anomaly is more. There may be a probability of getting the vision getting affected for this patient. So let us have one fundus camera check where the retinal image can be taken. They will add for an additional test. This is now done by AI in a bigger manner. Why I gave this example is AI is finding this as a very, very best example. There are clinical observations given as a data to the AI algorithm. AI is able to use these values with a huge volume of the different parameters of the concerned patient and is able to give you a prediction. The person is having the actual issue towards vision problem. So please analyze. So such inferences are great boon for the doctors where it's able to give them as a facilitation systems today. So AI is also a very, very helpful solution for every field we can say that I need not explain, you people are experienced. So moving on now. Okay, so far I have told you in brief what is IoT, what is AI, and what is major health monitoring. Now, what is that we are expected to do, right? So I have already told you the sensor is nothing but new, like you are already having a usage of sensor in many places. Even when I say in my mobile phone, mic is a sensor where my audio is converted into a signal and it is getting transmitted starting from mic and the speaker. There are a lot of sensors available within a mic, within the mobile phone too. So sensors are common. So now, what's our botheration? In a crane health monitoring, what are the possible sensors? I'm trying to help you for thinking about your solution. If you wanted to have any problem related to the structural health of the crane, you can use strain gauge, accelerometers, or displacement sensors, which may be able to give you the different parameters like the stress and strain faced by the crane, vibrations are happening in the crane, the deformation happening in the crane because of the load. They can be sensed by these kind of sensors. The load, exact load measurements for the weight, load cells can be used, tension sensor, the rope and the cable tension could be measured, torque sensor. These are all the possible sensors. Motion can be sensed by the inclination sensor, gyroscopes, encoders, GPS. Having multiple sensors will give me a better history about the behavior of my crane. Please use this kind of an invariant technology, the invariant analysis. If I depend on one sensor value, I may not be able to predict the problem on time. one accident, if I have after the usage of the technology, it's not a successful project. Am I right? So having multiple sensor values, if I'm able to develop an algorithm which is able to tell the health of my crane, that's a huge boon of solution for the community of the crane users. So these are all the list of sensors. Motor and electrical system can be sensed by current and voltage sensors, and thermal cameras can be used. Wire rope gear can be sensed by some ultrasonic sensors, eddy current sensors. It's available information you can also gather from the internet anywhere. The brake of the crane can also be monitored by proximity sensors, brake sensors, LiDAR or radar sensors. So these are all the sensors possible. As I have given you earlier, the kind of the flow chart, please fix the sensor. This is the list of sensors corresponding to your problem. You can choose the sensors. Next comes, I have to fix the sensor and allow the signal to a controller. What are the possible controllers you can think of for your solution? ESP32 is one particular typical board which you can make use of. I have listed some of the controllers which are conventionally used for exploring the kind of algorithm what you are trying to address with. And the concern integrated development environment in the programming language also I have listed for your comfort. If you're already aware of Arduino IDE, then you can think of solutions with the help of ESP32. It is also give you the wireless solution also. STM32 is another choice. STM is widely used for many of the solutions in the industrial solutions. STM32WB is having the wireless support too. But for those things, you can have STM32 Cube is the IDE and embedded C is the code. Raspberry Pi, if you go with the Tony IDE and MicroPython, can help you, where this Raspberry Pi CM4 easily supports the AI-driven solutions. So these are all some multiple versions of the controllers you can think of while you're developing the solution. Okay, you have chosen the sensors. You're able to fix some controller. What is that you have to do? Connect the sensor, code it using this particular language in the IDE, become familiar. Now next is we have to connect them for an internet, correct? So that try to have these boards to be connected with cloud, right? For such solutions, you can have the cloud choices. There is a ThinkSpeak and Adafruit. Adafruit supports any of your hardware boards to be connected with. It's a free cloud. So Adafruit you can play with. ThinkSpeak is while you're using any simulators, it can help you as a cloud choice. Simulators for the embedded solution, you can also play with the Tinkercad. Without buying any hardware, you can play some solutions. But Hackathon is a competitive solution. If somebody is able to demonstrate with the hardware at the real hardware cloud of an Adafruit, you will not be able to get considered if you're working only with simulation. Simulations are helpful for you to have an understanding. If you're in a batch, one of you can work for a simulation, the others can try out with exploration of the hardware and all that. Walkthrough is another interesting simulator. That simulator has got multiple boards to be supported. And it is also possible to connect the Walkthrough with the ThinkSpeak. ThinkSpeak is the cloud environment. So you will be able to ultimately show the every IoT solution with the help of Walkthrough and ThinkSpeak. And Proteus, I have not used. I have used it for only for PIC microcontroller, but cloud integration and all I have not tested. So I don't have any experience to share with the others. We have an experience, right? So these are all some solution choices you can think of. Now, is it only I'm collecting the data and pushing it to the cloud? No, you have to apply some kind of an optimization you can think of. So for that, you can choose some research-based algorithms, grid-based algorithms, triangulation-based algorithms may help you if at all you are playing with the structural health monitoring. Load monitoring can also be done by some kind of a triangulation and clustering algorithm. It's only an option I'm talking about. And if you look at mainly coming to the AI models, you can use SVM. See, these kind of informations, if you search, really you will get because you are living in the information world today. But your prompting should be opt in such a way to get these kind of informations. So suppose if you wanted to classify the vibration patterns in order to detect what fault has occurred in the grid, you can think of support vector machine algorithm in the AI. So the different models will have a different purpose. So I have listed some two choices for you to have an understanding about how this can help you while you are developing your solutions. Grouping the sensor data to detect the unusual behavior, you can use k-means clustering, which will be able to group the values and it should be able to give you a solution using the AI model. So you can play with the AI on the other end after the data comes to the cloud. Okay, so this is how the entire project flow you can think with. So in summary, We had an overview on the industrial requirements and practices and how to have a methodology of approach of one of the proof of concept for the crane health monitoring. I have given you an idea. I believe this is a useful information for you. Open for queries now, anything, so that we can have a discussion.
Thank you, ma'am. Thank you for that insightful discussion and insightful information. We are open for the problem questions. There are some general questions, I guess.
Yeah, I think
Yeah, I'll
Yogesh
take
has
them.
asked something.
So there are almost 8 problem statements posted. However, my expertise lies in generative AI and wave technologies. So whatever your expertise are, we will suggest that stick to the problem statements. So your expertise are into generative AI. So look at where this expertise can be used to solve the problem statement given. So now the hackathon and the problem statement revolves around the crane industry, material handling industry. So I request you to use your generative AI expertise in solving those problem statements related to that industry. Integration of hardwares is quite not necessary at the initial stage. You can use simulation. As you also had another question. Prototype development, do we need to purchase required hardware or we can demonstrate solution? Yeah, you can demonstrate your solution using the simulation, but the Arduino and other kinds of sensors generally are available in cheaper cost. So if you could make a demonstration, this will be very helpful for like uh, explaining the solution, and demonstration will help you get more points. So we had someone raise the hand. If someone had raised the hand, could you please post your question in the chat box, or you can raise the hand again. Any questions related to the concepts that ma'am explained right now, or any other problem statement related to IoT or the AI use case of AI? I like the use case that ma'am mentioned about diabetic monitoring. It's quite very important nowadays. Diabetic management is also using AI to like monitor it and do the diagnosis. Any more questions? Please do ask questions related to any other, like if you have any questions related to the sensors or any IoT or any programming language, we are open to that.
I think there are no more questions further.
Yes, every participant is smart enough. They have learned everything.
Anyway, I think we could start for them. Let them just do some solutions. We will just meet them in person when they are coming with their solutions.
Sure.
Yeah.
We will take if we will also take questions offline. If you have any questions after the session, you can mail us at support@ifoc.in. Ma'am is also available for the entire hackathon as the mentoring. If you have any questions to her, you can again put the question to the support@ifoc.in. And once these when the semi-final of the hackathon is done, the idea selected will be mentored by the ma'am on one-to-one basis. So this is very great chance to learn you from the expert. So please do submit your ideas. Okay, I guess. Sure.
Yeah, I think there's a doubt raised by Mr. Arumugam. Yeah, can you put your question in the chat box, Arumugam?
Yeah, Arumugam, you can unmute yourself. I have allowed you the mic.
Yeah, good evening, sir. Am I audible?
Yes, sir.
Yeah, so I'm the SPOC for the Venkateswara Engineering College, Chittoor. I hope you recently visited our institute
Yeah,
for
yeah.
SIH grand finale.
Yes, yes, yes.
Yeah.
Thank you for joining.
Sir, this, for students, I'm preparing almost 7 to 8 teams. I'm preparing from our institution. The idea submission, it will be done through SPOC portal or directly they can upload their ideas.
If your students have directly registered as team captain or team, they can post their own ideas on the portal. That's fine with us. So we have reduced the headache of the SPOC that every time a new team will come and then you have to upload the idea. So there is no need of that. Team can directly register and submit their idea.
Okay, sir. Thank you.
Thank you. Okay. I guess we don't have any further questions.
Yeah.
I'd like to thank everyone for joining this session and thank you, ma'am, for this wonderful session.
Yeah,
And I guess participating in this webinar will help the participants design the solution for the hackathon, and they must have gained knowledge with direct, which will definitely help not only for this hackathon but their further journey also.
correct.
Yeah. So, again, I encourage all the participants to please do participate in the hackathon, learn more, innovate. Thank you.
Thank you, Saurabh. Thanks a lot. Thank you, all the participants. Thank you.
So we have our upcoming webinar also coming on 12th of February, 10th of February by Bharat Kate, which is on sensor integration and real-time software development. So he is also one of our mentor and he is head at the embedded systems. So please do join, do register and join the upcoming webinar.